So we have been given in this question that Ks is equal to 10 millijoule, and by that we can come to know that this is 5 and this is 15 millijoule. So the maximum kinetic energy is equal to 15 millijoule in this question. Now it's given that the pendulum bob has a mass of 0.2 kilogram and it's asking us to determine the length of the pendulum. Okay, so given the maximum kinetic energy, we can determine the velocity from it, and also determine from that the length of the pendulum. So just to give you a review of the energy in a pendulum, so suppose this is the maximum angular displacement of the pendulum, and this is the equilibrium position, which is at this is at theta is equal to 0, and then it goes to another location at theta is equal to minus theta max. Now at this point we know that the velocity will be like this, and then momentarily the velocity would be 0, and then it would return back this way. So at this point the velocity is 0, which implies that the kinetic energy will also be 0 at this point, which makes this point have the maximum potential energy. And at this point we can take this as a reference level, which gives us the potential energy to be 0 and the kinetic energy to be maximum. Now let's assume this distance to be h and the length of the simple pendulum to be L. So this will give us L cos theta max, and this will give us L sin theta max. Now we know that at this point, when the pendulum is at here, this total distance is L. So h is equal to L minus, or we can write length, the total length L to be L cos theta max plus h. So L minus L cos theta max is equal to h. So h is equal to L 1 minus cos theta max. So we got h from that. Now we can apply energy, the conservation of energy principle, which gives us that delta Ke plus delta Pe is equal to 0. The change in kinetic energies plus the change in potential energies to be 0. So let's assume this to be the point 1 and this to be point 2. So the first one will have 0 kinetic energy since the velocity is 0, and 0 minus, at this it would be maximum kinetic energy. Let's call it m max square, half mv max square. Potential energy at this is maximum, which is the change in the height, which is mgh, and at this we'll assume it to be 0 at the reference level. So from this we get mgh is equal to half mv max square, or m cancels out, v max square is equal to 2gh. So we have v max square is equal to 2gh, or 2g L 1 minus cos theta max. That is the v max square, or v max can be written as the 2g L 1 minus cos theta max. Now we have the maximum kinetic energy from this diagram to be as 15 megajoule at theta is equal to 0. So applying the equation for kinetic energy as half mv square, we get 15 into 10 to the power minus 3 into half m v max square. So solving for mass m equal to 0.2 kilograms, we get the v max equal to 0.387 meter per second. Now substituting in this equation right here, we get 0.387 square is equal to 2 into 9.81 into length, which we need to determine the length of the pendulum, into 1 minus cos theta max. Again, we can look at the diagram and say it is 100 milliradian, and minus theta m is minus 100, minus theta m is minus 100 milliradian. So theta m, we can write it as 100 into 10 to the power minus 3 radians. Remember to change the scientific calculator in radians mode, and then we can determine cos of 100 into 10 to the power minus 3 radians from here. Solving this equation leads length of the pendulum to be 1.53 meter. So this is the answer for this question.